Welcome to the r.avaflow tutorial video. Today I'm going to show you the basic functionalities of r.avaflow and how to get started with your first mass flow simulation. For the first step, you need to go to the website landslidemodels.org, which can be found in the video description. In this tutorial we're going to use the Windows version of r.avaflow, therefore you need to select r.avaflow 4.0 W and download the executable file. To run r.avaflow on a Windows machine, we need Cygwin. You can either download it from the homepage of Cygwin or use the cygwin.dll file that is provided in the video description. I recommend using the Cygwin DLL file. The second thing we will need to run our first simulation is data. For this tutorial, we're going to use the provided data on the website landslidemodels.org. The data can be found under the link Cascadia Generic Landscape, and the data is already in the correct form and can be used immediately. When you open the Cascadia Generic Landscape folder, you can see multiple text files as well as the data itself. The text files are the so-called parameter files, which contain preset parameters for multiple simulation scenarios. In this tutorial we're going to use the first parameter file for the first simulation scenario. To develop and/or load a pre-existing parameter file, you need to go to Develop and Save Parameter File. With Import Existing r.avaflow Parameter File, you can now load the first parameter file of the Cascadia Generic Landscape. When you load other pre-existing parameter files or develop your own file, you need to know if it's a one-phase model or a multi-phase model. Our file that we are using today is a one-phase model. No matter if you are using a pre-existing parameter file or develop your own parameter file, you need to set your indirectory for your input data. Please check if you used a trailing slash for your file path. When the indirectory is set, you can have a look at all the other parameters. As you can see, you can click on every individual parameter to get more information about it. Okay, since we loaded our parameter file, we already have the correct file paths to our raster data. For example, here elevation. But I will show you anyway how to load your data into the parameter file if you set up a new parameter file and don't use a pre-built one. And it's always a good idea to check if the file paths are correct, even if you use a pre-built parameter file. If you check all the inputs for the parameter file, you will notice that some of the inputs are empty. That's okay, you can add more data into your own model and your own parameter file. The last thing we're going to need for our parameter file is the file path to R. If you don't have R installed, please do so and use the correct file path for your parameter file. In addition to R, we need some R packages to calculate maps of our results. As you can see, I have all my R packages that are needed to properly visualize my results in one folder. I recommend you do the same. I will provide the folder with all the R packages needed in the video description. For more information about the R packages, check the website landslidemodels.org or contact us. When everything is set, we can create our parameter file. The next step is to create the start script to run our simulation. To set up the start script, you need to choose a working directory, so a file path where your results will be stored. In contrary to the parameter file, we don't need a trailing slash for these file paths. When you have set up the start script with all the needed information, you can use the button below to create your first r.avaflow start script for Windows. Now we have everything that we need to run our first simulation with r.avaflow. To start the simulation, you could either double-click on the .cmd file or use the Windows command prompt. When using the Windows command prompt, you need to navigate to the correct file path and open the CMD file. Be aware, if an error happens, the command prompt will close immediately if you open the CMD file directly. So I recommend using the Windows command prompt as shown in the video. When the simulation is done, you can navigate to your working directory and have a look at the results. I hope this tutorial was useful and I wish you lots of fun modeling with r.avaflow.